Recording in progress.
So this is the last question for vectors, and that's it, right? We finish all the past papers. So once you're able to answer all the questions on this PowerPoint and you understand all the content on the PowerPoint, you're good to go, right? Because I put what I put on the PowerPoint, it answers all the syllabus objectives. So once you know what's going on the PowerPoint, you're good to go. Right, last question. P and Q have position vectors 10 I hat minus 8 j hat and beta I hat plus 10 j hat, where beta is a constant and OP and OQ are perpendicular. Find the value of the constant. So I actually asked you to do this for me, but only one person sent me the answer. That's cool though, because we're doing it now, right? Just for the people who weren't here, this question comes under this whole subtopic dot product, right? So you know you're applying the dot product here. And we said before that if two vectors are perpendicular to each other, that means that their dot product is 0. So for the people who weren't here, what does dot product mean? That just means multiplying two vectors, right? That's how I multiply two vectors. I find the dot product, and it's also called the scalar product, right? So when I multiply these two vectors or find their dot product, because they're perpendicular to each other, the answer should be equal to 0. So let me just write that up. Let me continue in red. So OP dot OQ, remember to put your arrow on top, right? I just couldn't type it out. Dot OQ, so that dot represents the dot product. And it means I'm multiplying two vectors, right? Since they're perpendicular, when I multiply these two vectors or find the dot product, the answer should be 0. And we said to find the dot product of two vectors, it would be, okay, let me just write this out. This is what I have on the PowerPoint, right? So if I have a vector that's defined by this column vector here, the top number is the x component, bottom is the y, and I have another vector b. Let's just say the x component is c and the y is d. If I want to find the dot product between the dot product of these two vectors, aka multiplying the vectors, what you do, a dot b is equal to the product of the x components, so the top numbers. That's a multiplication sign, right? Anyways. The product of the x component, so the product of the top numbers, plus the product of the bottom numbers. That's how you find the dot product of two vectors, right? So if I want to find the dot product of OP and OQ, it's the same thing I'm applying here, right? Let me just erase this. I'll leave the green part. So OP dot OQ would be the x component. So remember the x components are the numbers that come right before the I hat symbol. So that will be 10 and beta. So applying this rule here, the product of the x components would be 10 multiplied by beta plus the product of the y components. And when it's in this form, in terms of I hat and j hat, the y components are the numbers before the j hat symbol. So that's minus 8 and plus 10. So that's minus 8 multiplied by 10. And because I know these two vectors, OP and OQ, are perpendicular to each other, this answer, when I simplify and all that, should give me 0, right? And that's how I'll be able to find the value of beta. So 10 times beta is 10 beta. And just put the addition sign. Minus 8 multiplied by 10, that's minus 80. That's minus sign, minus 80. You give me 0. I add 80 on both sides, so end up with 10 beta is equal to positive 80. And then divide both sides by 10 because I want beta. So beta has to be equal to 8. And that's the answer. Do you understand that? This is what we were doing before, nothing new. Do you understand that? Yes or no? Is there any part you're unclear about? Okay.
Yes, miss.
All right. Well, that's it for vectors. Let me just stop sharing this real quick so I could move on to rates. Okay. This is on the differentiation, right? Let me just show you the, before we do that, let me show you the objectives. This is for kinematics. Rate comes under differentiation. Right here. So it's under differentiation, right? Sub-objective 11, use the concept of derivative as rate of change. So this applies to real world applications, and they include kinematics. So we're not doing that yet, right? We'll do that just now. Kinematics. Rates of so rates of change for area and volume and kinematics. So for your exam, that's where you're required to apply your knowledge of rates of change, right? When calculating the rate of change for area and volume, and then for kinematics. But we're not doing kinematics right now. We're doing that after, right? We're doing this right now for area and for volume, right? So just know for your exam, expect to see a rates of change question for area, volume, kinematics. Can you please post that PowerPoint? Yeah. So right, area and volume, right? That's what we're doing. So I decided that it would be best to do questions with you and you ask me whatever you're unclear about, right? So just write down the first question for me. The length of the side of a square is increasing at a rate of 4 centimeters per second. Find the rate of increase of the area when the length of this side is 5 centimeters. So just write this down for me and let me know when you're finished. Let me read that one more time. The length of the side of a square is increasing at a rate of 4 centimeters per second. You see this phrase right here? Increasing at a rate of whatever. Because of that phrase right there, I know this is a rate of change question, right? Just by that phrase. And of course, you know, because I told you that's the topic, right? But let's just say you, in your exam, and you read a question, you see a phrase like this, talking about at a rate of whatever, you know that's a rate of change question. The rate of increase of the area, find the rate of increase of the area when the length of the side is 5 centimeters. So there are 3 things you want to note when doing rates of change questions, right? I try. So the first one, you see when they're talking about rates, so you see rate here. So the first thing you want to know is whenever talking about rate, they're talking about something on dt. So let's say it's area. Area would be dA on dt. Rate, for my physics students especially, you would know that whenever you hear that word rate, it means with respect to time. And that's why whenever you hear rate, it's always dt in the denominator, right? So because they tell me the length of the side of the square is increasing at a rate of 4 centimeters per second, they said length is increasing at a rate of whatever. All you do here, let me say I want to represent the length as L, it's dL on dt. So it's whatever quantity they want you to find the rate of, it's on the top. So they said length of the side, so that's why I have dL. But because they mention rate, rate means with respect to time. So it's always over dt. That's why the length of the side of a square increasing at this rate would be represented as dl on dt. Do you understand that? If not, I will explain another way. Yes, okay. Right. So that's the first thing I want to note, right? Rate means whatever the quantity is over dt. The next thing you want to note for rate questions, you have to apply the chain rule. Well, something like the chain rule. What do I mean by the chain rule? So like I said, non-exam students who didn't do differentiation yet, you could ask me after, right? But this is mainly for the exam students who already, covered differentiation and we just doing rate of change. So chain rule, for those who did differentiation, you would know one way to represent the chain rule is dy on dx. So if I want the rate of change of y with respect to x, it's dy on dx is equal to du, well, dy on du by du on dx, not du on dx. Yes, du on dx. So dy on dx is equal to dy on du times du on dx. Are you familiar with this rule? It's another way of representing the chain rule. Right. So that's the first two things you have to note, right? Whenever they say rate, means with respect to time. Inside times outside. Inside times outside. I've never heard that expression before, but like, if that helps you to remember it, sure. So the first thing for rates questions, whenever you see rates or whatever, you know it's over dt because rate means with respect to time. The second thing you want to note is kind of applying the chain rule here, right? So you're always going to apply this. dy on dx is equal to dy on du times du on dx. And for those who have trouble remembering this rule, it's almost like this du and this du would cancel each other to give me the dy on dx. Do you understand that? I mean, that doesn't really happen, right? This is just to help you remember. The du would cancel with this du to give me the dy on dx. Do you understand that?
Yes, ma'am.
Okay. And there's one more thing you need to know. So you hear rate is on dt. The second one, you're applying this chain, right? The third thing that you need to know, because your rates of change questions, if it's not kinematics, then they're going to give you a question on volume or area. The third thing you need to know is that you need to actually know the formula for the area of whatever shape or the volume of whatever shape they're asking you for. And if you're wondering why, when we do the questions, you'll know why, right? But just know that the third thing you need to do, you have to know if they're asking you for area, they're asking me for the rate of increase of the area, right? And they told me that the shape is a square. So one time you need to know that, okay, they want me to find the area of the square, area of a square, which is side by side, or you might say side s squared, right? Oh, well, I use L. So it's whatever you want, whatever you want this, your symbol to be. So yeah, let me just leave the S because that's, common symbol finding the area of a square. So because they want the area of a square, I know one time that I need to apply this formula somewhere side by side. That's the area. down here, just look down here for a second. They told me a spherical balloon of volume this, right? So this is the formula that I would be using for the volume of a sphere. For this one, they talked about a cylindrical container volume. So I need to know the volume of a cylinder. For this one, circle, they want me to find the rate of the increase of area. So because it's a circle, I know the third thing that I must know is what is the area of a circle? Pi r squared. So that's the three things you need to make sure you know before you start any rate of change question. Do you understand that? L squared, yeah, you could use L squared. It doesn't matter, right? Whatever your symbol is, once you know what's going on. Okay, so keep those things in mind, right? Whatever it is on dt, that would represent the rate of whatever. Chain rule, we need to apply this somewhere. And the third one, they would either ask you for the area or for the volume. What you need to do is find out what they're asking you for. For this one, they said area of what shape? A square. So you need to know, okay, the area of a square is side by side. For this one, it was for a sphere or spherical balloon. So, and they want me to find, well, not this, right? But they said volume. What is the volume of a sphere? The formula is 4 pi r cubed, right? So let me just do the questions now so that you can see how exactly we apply that. Let me just erase all this, erase. Okay. Let me just read it one more time, right? Because I need to make sure you follow, and this gives people some trouble. I know that. The length of the side of a square is increasing at a rate of 4 centimeters per second. Find the rate of increase of the area when the length of the side is 5 centimeters. So let's go. So if you look down at your question, can you see you're using substitution in differentiation here? You're using substitution in differentiation. Can you explain what you mean by that? Okay, while you type that. Okay, okay. Right. So note the first line, they told you that the length of the side is increasing at a rate of 4 centimeters per second. The minute you see rate, remember it's on dt. Rate means with respect to time, dt. And they told me that the length of the side is increasing at that rate, the length of the side. Let me just say I want this side to be represented by S. So to represent the length, the rate of increase of the length of the side, and with symbols, it would be ds on dt. I just chose S to be my symbol for the side. You could use L for length. It doesn't matter, right? And they told me that this is equal to 4 centimeters per second. And it makes sense, this unit, right? Because length is in centimeters, time is in seconds. So if I wanted to calculate the units, let me just show you centimeters on seconds. This would in fact give me centimeters per second, right? Just in case anybody did not understand where that unit came from, or you might see some people represented as centimeters per second, like with a slash. Yeah, just in case you didn't know where that came from, right? So the next thing I told you that you have to use for rate of change questions is you actually have to use your knowledge of this chain rule. And we said dy on dx is dy on du times du on dx. That's just one way to represent the chain rule, right? And I said a way for you to remember it is that this numerator, this denominator and this numerator would cancel in a sense. I'm using that very loosely, right? Because they don't actually cancel, it's just to help you remember. So this denominator and this numerator would cancel to give me the dy on dx, the dy on the dx. That's just to help you remember, right? So what exactly did they ask me for? Well, they asked me for the rate of increase of the area. Again, they mentioned this rate thing. So I know what I'm trying to find is something on dt. Why? Because they said rate. So with respect to time, dt. And they said the area, the rate of the area. So this on top here would be dA, where A is my area, right? And this is actually where this chain rule here comes in. I want to find dA on dt. But how exactly would I do that? Well, referring to this form, well, this rule on top here. dy was on top, so dy comes here. In this case, let's just say my dy is dA, right? So dA would be here. I see dy here, I put dy here, right? See dA, I put dA. On du, but what exactly should I put in this case? Hold on, right? Just hold on. Du on dt. Give me du on dt now. Du on dx. What exactly can I put here? Well, that's where this comes in. My du on dx would actually be the ds on dt. And how would you know what to put down here? Well, go back to this rule. These two, in a sense, should cancel to give me the dy on dx. So what does that mean down here? This should be ds, so that these two would cancel. Like I said, I'm using that loosely, to give me the dA on dt. Do you understand that? That's how I know which order I'm putting them in. No, we're using a connected rate of change. It's ds. I don't know what you're talking about because I now seen that message. But anyways, do you understand this? Okay, fairly easy. Anybody is not following what just happened there? Okay, nobody's saying anything. I got a fairly easy, so okay. So that's the first thing I told you to look out for. The second thing I told you to look out for. So you have this now, right? We know that this is what we're working with. In order to find my dA on dt, which is what they asked me for, the rate of increase of the area, I know I need these two things. I already have ds on dt. They told me it's 4. But what is dA on ds? You need to find this if you want to figure out what this is. That's where this third thing comes in. Remember I told you, pay close attention to what they're asking you for. In this case, they ask you for the rate of increase of the area. So area, we know we're dealing with area. An area of what shape? They said it was a square. Area of a square. What's the formula for that? Well, we said we're using S, right? Somebody just said something. Am I hearing things? Okay. Area of a square. And we said we're using S, right? So that's S times S, or we could just say S squared. So let me just write on that. Let me just write that in a different way. Area is equal to S times S. Side by side, right? That's how we find the area of a square. So let's just say A is equal to S squared, because we know anything multiplied by itself, it's the same as saying whatever it is squared, right? S times S is the same as saying S squared. But that's not what we want to find, right? We want dA on ds. But how exactly can I use this formula for area to help me to find dA on ds? Well, this is why you're required to know the basics of differentiation before you start rates of change, right? dA on ds, that's what we want to find. How exactly do we do that? Well, all we have to do is apply our rule of differentiation. What does that rule state? So if I have, let me just say ax to the n. So it's just two random things, right? Ax to the n. So let's just say this is y is equal to ax to the n, and I want to find dy on dx. Then my differentiation rule says that I would bring this power to the front, so it would become n multiplied by ax, and then you subtract 1 from the power, so it would now be n minus 1. That's how you differentiate, right? For the people who never met differentiation before, integration was when you add 1 to the power and then divide everything by the new power. For differentiation, see this power on top here? You multiply everything by the power on top, and then you subtract 1 from the power. That's how you differentiate, right? That's a basic rule of differentiation. So if I wanted to differentiate this right here, s squared, I would take the power and put it to the front. So it'll be 2 multiplied by s, but this power would no longer be 2. It would actually be 2 minus 1, which is 1. And therefore, dA on ds is actually 2s. Do you understand that? Well, you don't need to know differentiation for rates of change. I was just mentioning something for the people who never met differentiation before. Do you understand how I got 2s? Easy. Makaya, you good there? I know you didn't do differentiation yet.
Yes, I'm fine. Just taking a while to process it.
Yeah, it will take a while because we're kind of jumping into more advanced, topics before doing the basics. So it would be a bit difficult for you to follow, right? So I'm sorry for that. But I'm glad that, you're kind of keeping up. Wait, how much time do I have? Okay, that's enough. Right. So I have everything I need to find dA on dt, right? That's what I'm trying to find, dA on dt. So what do I do now? I want dA on dt. I already have this ds on dt. I erased it, right? But it's the 4 centimeters per second. And dA on ds. I have that now, it's 2s. So there are two ways to do this. You could go ahead and say, okay, dA on ds is 2s, and then ds on dt is 4. And you simplify this and you say it's 8s, right? But they told you they want the rate of increase of the length when the length of the side of the square is 5. So what does that mean? They want the value for dA on dt when the value of s is 5. So let me just erase. Use a different color. And just continue with orange, right? So they want the rate of increase of the length of the side of the square when s is 5 centimeters. So when s is 5 cm, they want the value of dA on dt. So then you would say that dA on dt is actually 8 times 5, which is 40 cm squared per second. Why cm squared per second? Because area, if the length of this side is in centimeters, right? Then the area, the unit for the area would be centimeters squared. And then we know the unit for time is seconds. So centimeters squared divided by seconds would give me centimeters squared per second. Do you understand that? How I got that unit?
Yes, miss.
Okay, hold on. Always mix it up by mistake. Mix what up? Differentiation and integration. Yeah. The only way to get over that is to practice, right? Practice makes perfect. So do you understand how I got this answer to be 40 centimeters squared per second? And why I didn't stop at 8s? Yes, you could say that. Great, I got that as well. Great. But like I said, some people, okay, they found dA and ds is 2s, so they substitute that, they got 8s, then they substitute the value of 5, right? But some people prefer to, some people, hold on now. So some people prefer to substitute the value of 5 one time, right? So let me just erase this whole left part here. Erase. Not the blue. Everything else. Erase. So you see how I got my expression for dA dt to be 8s, and then I substituted the value of 5. Some people like to substitute the value one time, right? So they say, okay, dA on ds is 2s. So let me substitute the value of 5 one time when s is equal to 5. Then 2s has to be equal to 10 because 2 times 5 is 10. And then they would go back here and say, okay, dA on dt is dA on ds times ds on dt. I know dA on ds is 10. ds on dt, which it gave me, is 4. So 10 times 4 is 40 centimeters.